All right, now we'll get to the fun stuff. So Storm allows you to create custom logic in its bolts, which when stitched together help you identify patterns in the data. The simplest way of understanding this is through an example, suboptimal network speed. Identifying suboptimal network speeds is important to understand degradation in network performance. So how did we figure out the suboptimal network speed? We used R to do some initial analysis to define what that suboptimal speed is for the given data. We also used R to prototype models for pattern matching. We then created the topology in Storm, complete with spouts and bolts, to identify patterns in the data. So in this case, we're identifying suboptimal network speeds. So this is an example for topology that identifies suboptimal network speed. So here, in the topology, you have the Kafka spout, which listens on a Kafka topic consuming the incoming stream of tuples. So as each and every tuple comes into this topology, it gets processed and emitted to the next bolt. And then the bolt acts back to the spout, as Fausto mentioned before. So here you can see when the first tuple comes in, it goes to the pre-processing bolt. Here we do some preliminary analysis, such as parsing user agent strings to get device and OS information, extracting timestamp information, filtering on event types, and so on. From here, it gets emitted to the sessionized bolts, where the data gets sessionized. The idea is to be able to compare the user's speed across multiple sessions. In the next bolt, we calculate the network speed per user IP per session. The speed is calculated as a function of size and time. It's a running average. This bolt maintains the speed per user IP across the multiple sessions. And then this bolt identifies the actual speeds that are less than or equal to the suboptimal threshold that we have defined for our data. The final bolt extracts the information that we need and stores it in a column family in Cassandra. From here, we can use it for additional batch processing, real-time processing, as well as visualization. So as Fausto mentioned earlier, Storm facilitates parallelism by allowing multiple bolts to run at the same time on individual executors. So here you can see two tasks running in parallel. Now, an obvious advantage of this is higher throughput, but the other thing it can guarantee is that all tuples, say belonging to the same user IP, get processed together. How does Storm do this? It has something called fields grouping. So say I group on the field user IP, it guarantees that all tuples belonging to that user IP get processed together in the same bolt. So here there's a quick animation showing you that. So as the tuples come in, you can see that all tuples belonging to user IP1 go to its task and get processed together, and then tuples belonging to user IP2 get processed together.